The U.S. Army Research Lab is working with industry and its own scientists to engineer new kinds of casings for ammunition to make them lighter weight, longer range, different kinds of geometries, different kinds of explosive configurations. The idea is to better address the Army's emerging program, which by the Secretary not long ago was called the #1 modernization priority. It's called long-range precision fires. The effort is to both engineer a missile that can fire as far as 500 kilometers and artillery that can more than double the historic range of about 30 kilometers and still maintain precision targeting.
So we're developing novel materials that are very high strength, very high toughness, that we can make complex geometries out of in order to transition that to our partners to make weapon systems out of. Rockets, artillery rounds, missiles, cannon rounds.
They're looking at things like titanium, different kinds of new materials, metal alloys that have an easier time traveling long distances. They're also specifically looking at engineering alternative or different ranges of fragmentation patterns. The concept is to have tailorable rounds depending on the specific threat, whether it be anti-personnel wanting something to disperse and fragment more broadly to attack groups of individual fighters, or something that's more penetrating and perhaps a more narrowly configured explosion to attack armored vehicles or various fixed infrastructures. They're looking at what they call complex geometries.
To get better penetration effects, so we can be able to penetrate certain targets that we couldn't before. We can make complex casings so that we can redistribute the guts of the projectile. So for example, for a round, we can put explosive and things within the casing before, where it'd be a simple tube before. Now we can rearrange the insides to get more explosives, to get different payloads, different fusing techniques and combinations.
And it's all being done by emerging technology called additive manufacturing or 3D printing, and implement that into actual metal materials. Uses powder and laser technologies and various kinds of layering to take what begins as a computer design model. This is of great significance as it can enable the development of newer kinds of weapons casings. So the Army's ERCA, Extended Range Cannon Artillery, is a longer artillery tube, and it's intended specifically to match or outrange potential weapons from potential adversaries like Russia or China.
So eventually we want to be able to control how, when the explosives on the inside blows up, how that makes the fragments, the pattern, size distribution, velocity, all those type of things. Right now, if this would blow up, it would just kind of shoot out kind of randomly. There'd be a lot of fragments that wouldn't be usable.
The Army Vice Chief of Staff, in an interview with Warrior, talked about a variety of experiments with long-range precision fires to make that a huge priority and better offset the potential threats posed by various Russian weapons, which have substantial ranges as well. Longer range and tailorable fragmentation and munitions changes the equation tactically in a number of key respects. Army soldiers can attack at safer standoff distances, potentially destroy enemy fighters on the move, fixed infrastructure, troop locations. It can also destroy things like enemy air defenses to soften up air supremacy so that air assets can fly over hostile areas. Kris Osborn, Warrior Maven.